Hello and good morning, everyone. My name is Sebastian. I'm the Novice Prospect, and we are back to programming today. We were working initially on a monogame project, and we want to go and finish it. Let me go and make this a bit bigger. Maybe we'll put you to the side for now and say thank you to Gitlog. And it's just a fun way to sort of look through your entire Git history, sort of as a animated movie, as it were, to literally see how every single pushed commit is basically coming together. It's quite fun, but that's all it is. Anyways, if we want to remind ourselves of the chapters, maybe we were working towards making shaders happen, but for some reason or another, we couldn't do the shader compilation. It turns out that I was just being a little bit of an idiot, and really all we need to do is, instead of building this application for .NET 10, we just need to build it for .NET 9, because if we want to look at getting started and installing full Linux, okay, I did this wrong. I was meaning to have this in a new tab and setting up. So it tells you to install .NET 9. I have already done that this morning. And it's this wine effect compilation that I couldn't make work. And it essentially turns out, because we're compiling our software against .NET 10, and the shader compiler is essentially built for .NET 9, that's basically the problem here. Or was the problem. I have made sure that this path is existing, and I can confirm that I was able to do shader compilation as expected. That means for us, really, that I probably want to finish chapter 23, because I was working through the shader chapter, and I was noticing that parts of the code that were expected just aren't there. So I feel like we want to maybe go and fix that up. And so it basically goes through saying we need in the UI folder a new game scene UI, give them some fields, but let's just go through that and make that happen. Okay, so I have, as usual, my VS Code open here. Needed the make file to be there, which reminds me, git check out, git stash first, right? Git check out chapter 23. So we will work through this in a second. Git stash pop, right? Use not happy for some reason. We'll see. First off, game scene UI in the actual project. Okay. I feel like I want to have this in scenes. Or even better, we'll make a folder called UI. Does it? Oh, right. Yes. No, we have game scene UI, okay. And it, yes, inherits from container runtime, cool. We have the score format, UI sound effect, pause panel, resume button, game over panel, animated button for retry, and score text. Sweet. And then we have resume button click, quit button click, and retry button click. Those are just public event handlers. Um, then we have a constructor, which says doc gum wireframe doc fill. That all looks fine. Why are you not happy? You see there's a possible null value. Um, uh, then we have UI sound effect, content load sound effect, ending basically with Agile game over panel visual. Yeah. Create the score text, pause panel. You also have null values possible. Why don't we just go and do this? Make sure these are nullable, or we at least acknowledge that they may return null, but we just assume they don't. So that is game scene UI event. So on resume button clicked, and on retry button clicked, and on quit button clicked. Yep, we have all that. On element got focus, yes. Then we have show pause panel. This is all fine, I feel like. Yep. Then the last one is the draw call. Okay. Then we need to refactor our actual game scene. There's a slime, there's a bat. We have some, at a time I have some room bounds, the correct sound effect, score, UI, and game state. Okay. Then we have initialize, which is base initialize core on exit on escape is false. There's the room bounds which come from our actual graphics window. Alright, basically we are going in one tile height and one tile width in terms of our room bounds, because then that way we can ignore the outer border. Yeah, this is fine. We have then initialize UI. There's the events, initialize new game, load content. And so far so good. There's the update method. We have all this. There's the collision checks. So position away from slime. Basically making sure we're some distance away from our player character. On slime body collision is game over. Toggle pause. Which literally just shows the game over panel and says game state is game over. Then we have a draw method. Okay, now we're doing input buffering as well. Right. Yes, okay. So let's have a look at that, making sure we get everything properly together because I feel like I had forgot something. Maybe not. We'll need to see. Um, I need the slime object. Game objects. There's my slime object, right? So I don't see us having that input. Oh no, here's the input buffer of a cure vector 2, okay? And a max buffer size of 2, sure. Let's go and check through the initialize function. Makes a new list of segments. Stride is stride. Segment head is a new slime segment. Head at. There's the input buffer being initialized. Okay. Handle input. Potential next direction is 0. And you basically get from our game controller, basically whether we use a controller or our mouse and keyboard, if we say up, down, left, right, and say our potential next direction is basically a unit vector of x or y. And I think a unit vector is just if it's unit y, it's basically 0, 1. If it's unit x, is 1, 0. So like you just add or multiply by 1, I think. Yeah, that's exactly what I expected here. Unity unit y is a 0, 1, and if I did the same for unit x is 1, 0. Cool. Yeah, that's basically just saying we're moving in a certain direction or negative direction if we're, you know, moving in the opposite direction. Okay, cool. If a new direction was input, consider adding it to the buffer. So if the potential next direction is not a vector 0, and the input buffer count is smaller than the max buffer size, and then you validate against the input buffer count, validate against is a vector, which either returns if the input buffer count is larger than 0, so if there's something in the buffer, then you return the last item of the input buffer. Otherwise, you just return the direction of the 0th segment. Okay. Hey, boy. You come to see me? Oh, hey, boy. I see you. Yes, hello, boy. Yes, hey, Patrick, boy. Oh, yes. You're a good boy, huh? There we go. Sorry, I had to apply a patch there. That's just how it goes. Pardon me. Right. And only allow direction change if it is not reversing the current direction. Because then you would run into yourself. You can't do that. Yeah. And how do we do this? You basically say we have a dot. Was a dot product? Okay. We're still learning vector math as well. Vector dot product. The vector dot product or scalar product is a mathematical operation that takes two equal length sequences of numbers, vectors, and returns a single number. It measures how much two vectors point in the same direction, capturing their directional multiplication. So this is essentially what this breaks down to. And this is probably easier to read as the bottom. So the dot product of vector A and B of those two vectors is ax times bx plus ay plus times by So you take both x's, multiply them against each other, do the same for the y's, and then you add those two, and that makes yeah, that would obviously return a single number, which tells you essentially as a positive or negative number how much you're moving in a certain direction, I guess. That's sort of the core idea, I think. So we're assuming, like in this case, we have a vector of our a vector is 1, 3, and our b vector is 4, -2, which would basically be 4 plus -6. -6, it's -2. Okay. So the dot product of those two vectors is -2. Okay. You can do the same for against yourself. Well, I suppose, yeah, you can just say, hey, what's the dot product of the a vector, and you just duplicate that a vector and do the same operation. Fair enough. And if it's a negative angle, the angle is obtuse, so it's larger than 90 degrees, meaning the vectors generally point in opposite directions. Which, if we think about the formula we just had up here, we have a -2. So, we have one movement in the y direction going 4 up, or down, doesn't really matter. But then you have the other vector actually pointing -2. So, yeah, it's not moving in the same direction, it's moving opposite direction, essentially. At least on the y component of that vector. All right, okay. I guess you can live with that and just use it. And so basically what we're doing is we're checking if the dot product is larger than 0. Right, it's yeah, larger or equal to 0. And if it is right. Yeah, now I get it. If the dot product is negative, we're basically running into each other. That is literally the definition of what the dot product is telling us in this vector. And what we're wanting to make sure is that this dot product, this directional change, is not going backwards. It can go any direction but backwards, because you want the worm to go either left, you want to go straight on, or you want to go right. You don't want the worm to reverse, and yeah, you're crashing literally into your second segment and game over. So this makes sense. Cool. Then we have move. Get the next direction from the input buffer if one is available. So check if the input buffer is larger than 0, and say this is our next direction by just getting the next item and dequeue it. Yeah, removes and returns the object and at the beginning of the queue. So a queue is by definition FIFO. No, FILO. First and last out. So there's two systems in how you deal with data. One's called FIFO, first in, first out, meaning that's a stack. So whatever item you drop in on the top of the bucket is the item you have to remove before you can get to items below it. FILO is the opposite. You drop in items on the top, but the first item you can remove is actually at the bottom. So almost like a bucket dripping out the information at the bottom. So that's what your queue does. A queue basically takes the items all in at the top, but you're removing the very first item was put in. Yeah. So that's a first and last on. Can we just confirm that I got that right? Queue is philo, right? Why? Oh, the last element. Okay. That was just a misunderstanding in my translation. Essentially, last item refers to the latest item that we've put in. So it is actually FIFO, first in, first out. The first element added to the queue is the first one to be removed. So again, we're talking about the bucket, say, when we're just stacking items or we're just dumping items in. That very first item at the bottom of the bucket is the first one to come out again. Whereas on a stack, you just add items in the bucket, but to get anything from the bucket, you need to lift from the top. So that is Philo, whereas FIFO is the queue system that we're using. Okay, it was more from our own understanding. Yes, that's right, boy. I agree. Then we basically check where our head is by looking at the very first segment in our list of segments, and see where we're off to next, our next direction, move the current head to the new position, and basically see that the new 2 position is where the head was plus direction times the stride, so how fast we're moving. Then we insert another segment at the beginning, remove the last segment of our worm and just keep going. Right, makes all sense. This is all fine. Um, so basically this should work. Let's do a make run and see what happens. Okay. That was wrong. Options. Trying to catch this damn bat. Oh, I ran into myself. Whoops. No, you're not supposed to do that. And I ran into the wall. But yeah, this works like a snake or worm game is supposed to work. Cool. And then we should be on to chapter 24, right, which is our introduction to shaders. So let's look quickly at changes we have done. There's just a bit of formatting change there. And null error checks and making sure we're running on .NET 9. Okay. Chapter 23 really done. Change to .NET 9. And that's it. Right? Commit. Save all and commit. Sorry, that was a meme. Sync those changes up. Okay. Let's check if that got pushed. Yes, there's our changes. Good. We're gonna need a new pull request for that. From chapter 23 into main. Create that pull request and create a merge commit. Right, and off we go. Okay. Let's move you over, get in here, check out main, get pull, I guess. Not sure if fetch would have been the better option here, but we'll see. No, looking good. Let's see if we actually are still able to run on the main branch. Okay, good. So git check out the branch 24, not branch 24, chapter 24. That's not good. I was meaning to have you deleted. Git branch delete chapter 24. Like, why? There we go. That's what I wanted. Thank you. So we now want to talk about shaders. And maybe to remind ourselves what types of shaders there are and how it all works, right? So we have vertex shaders. They process the corners of the shapes that make up your game objects. They determine where these points should be positioned on the screen and can manipulate their positions to create effects like waves or ripples in water, swaying grass or trees, or character deformations for animations. Vertex shaders are especially important in 3D games, but they can also be used in 2D games for special effects that involve moving or distorting sprite positions. Okay. Even in 2D games like ours, Monogame actually draws sprites by mapping textures onto simple 3D shapes called quads, rectangles made of two triangles, and each quad has 4 vertices, one at each corner. While we do not normally think about these vertices in 2D development, they are still there behind the scene, and vertex shaders process them before rendering. Okay, and then we have pixel shaders. Sometimes they're also called fragment shaders. And they determine the actual color of each pixel that gets drawn to the screen. After the GPU figures out which pixels need to be drawn based on your geometry, the pixel shader calculates the final color for each of those pixels. And this is where you can do effects like color adjustment, visual filters, special transitions, and dynamic lighting effects. Okay. So we want to do a pixel shader in our case, right? Because we want to, yeah, we want to basically do a grayscale image, which is a visual filter. Um, what would be interesting? I'm on a little tangent here for a second. I went and had a little bit of fun with my monogame library that we sort of built for this project. Um, Basically, I made a little physics app. All right, and I'm thinking to myself. So this is literally just all it does. It's just a couple of bouncing balls that react to each other and the walls. Um, Now this is all done on the CPU. Like every single one of these collisions, every movement, all of that is done on the CPU. And this is fine for 200, 3, 4, 500, 600 balls, 700. It gets a bit messy down here at the bottom. I think my physics breaks there. 8, 9, and then once we get to like, no, sorry, yeah, to a certain number, it starts freaking out. So over 1,000 balls, it really slows down and pixel soup created. But this is something that you could then literally offload to a vertex shader instead of doing this on the CPU. Anyways, future set problems. We are wanting to be here. Let me go and clean up my window a little bit. So let's look at the pixel shader pipeline here for a second. So we give you a texture, you sample it, and you run it through a pixel shader where the vertex shader previously would actually make up the positions, right? And then you have an output which combines those two things. So really the vertex shader runs first, and then comes the pixel shader. Right. Um, this is basically just talking about different pixel language, sorry, shader languages, and which platforms to target. And when you create a new sprite effect FX in the Monogame using the MGCB editor, it generates a default template file. To get a feel for the language used in shaders, we can use this template to understand the foundations of what we build upon. Right. Let us, for now, look at this. I literally just copied this in already from the sample. So maybe we want to go and look at this quickly. Basically, what we're doing here is we're doing a bit of language definition. We're checking if we are in an OpenGL context. If so, we define these variables, or constants, I should say. Basically, which shader model and for which vertex shader and pixel shader, which shader model we're using, and SV position, which is probably actually it's a variable that we pass in. Okay, I see it down here. So basically you have a sprite texture sample which just gets the sprite texture in, a vertex shader input, takes that position, the color that's already been assigned to it, or we assign to it. Let's have a look. This declares the texture to the variable called sprite texture and it will receive the texture being drawn by the sprite batch. Okay. The sampler state. This creates a sampler 2D called sprite texture sampler that controls how the shader reads pixel data from the texture received from the sprite batch. It defines properties like filtering and addressing modes for texture sampling, similar to sampler state we discussed in chapter 18. Yeah, remember, somewhere in the back of my mind. And this is what the vertex shader looks like. Defines a structural vertex shader output with 3 fields: position, color, and texture coordinates. This struct represents the data that is passed from the vertex shader function to the pixel shader. Okay. And defines the passing of position of the vertex in homogeneous coordinates x, y, z, and w. Okay. The RGBA color of the vertex and UV coordinates for texture mapping. Okay. Right, main PS is the actual main pixel shader. It determines the color of each pixel. Default implementation simply samples the texture at the current texture coordinates and multiplies it by the vertex color, which is the color value supplied in the sprite batch DOM method call. Right, technique and pass. This block defines a technique called sprite drawing with a single pass called P0. The pass itself defines which shader functions to use. Basically, this is where you say you want to use the main pixel shader that we've defined up here with the pixel shader model that we've defined up at the top. Basically compile this whole thing together. Okay. Right. It's, yeah, basically what you would do is you would have these different passes of, no, you would have these different pixel shader functions that you would then say in pass 0 P0, for example, you do the main PS. In pass P1 you could then run another pixel shader over the result, and so essentially the technique is essentially what defines what we run in total, right? It's like the recipe, and then the pass is the single step in that recipe. Okay. Using effects with sprite batch, setting effect parameters. Let's make our own, right? So creating the shader file. There's the grayscale shader. This is let's actually just copy this code as is, and I should be able to just paste all of this in. So OpenGL is SV position, the shader model, no, vertex shader model, and the pixel shader model. And here's the actual pixel shader running, right? Where we have one single pass, P0, and it runs main PS, which we run up here. And so we say color comes essentially from our texture, and then calculated grayscale based value on human perception of colors. Float grayscale is the dot product. I don't. So you take the color red, green, blue component. So that's a vector C, right? It's gotta be. And then you basically we're doing the dot product of our actual color and this value here. Be interesting to see what color this would be, but I don't know of an easy way of doing that right now. But then we do the grayscale color, which is right. Right. Okay. So grayscale comes 3 times here because the red component will have a different result from this dot product than the green and the blue. So this is why we're just taking these grayscales in, right? Yeah, because you're multiplying each component. Right, no, it's the same value for RG and B. So you're taking essentially the color combination or the combination of 3 numbers that make a color, and you do the dot product against this fixed value, which gives you a grayscale pixel value or color value, which you're applying across all 3 color values. Okay, that makes sense. And then you lerp between the grayscale color and the original color. So the final color is a linear interpolation between the grayscale and our value and the saturation. Sure. And then you return that final color with the original alpha, so the original transparency. It's not all that terrible, except for, this mathing. It probably makes sense, but it would probably require me to have a huge understanding of like color theory. But somehow this makes a gray scale image cool. Um, maybe they will actually explain a bit better here. This uses the dot function to calculate the dot product between the color's RGB values in the vector 0.3, 0.59, 0.11, like so. This effectively calculates a weighted average where red contributes 30%, green contributes 59%, and blue contributes 11%. But why? These specific weights are based on how the human eye perceives brightness in different colors. Green appears brighter to us than red, which appears brighter than blue. Okay. The weighted values themselves are based on the formula that represents the luma component from the some standard ITU-RBT 601, which is commonly used for converting RGB images to grayscale based on human perception, where something. It's a standard originally issued in 1982 by the CCIR for encoding interlaced analog video signals in digital form. Includes methods to encode different signals with both an active region. I'm not sure why we come up with those numbers. Something dark side. I mean, the numbers look almost familiar here. It's like we've got 30%, 59% and almost 60%, and it's not quite the same, but it's close. But why? Okay, we're just gonna have to assume that it's the truth. Hey, my username is gone. Welcome in. How you doing? Why? Why does green appear brighter than red, which is brighter than blue? I don't.
Green is a colour that is made using bright colours.
This is about perception. This is.
Yes, but green is made with bright colours, whereas red's not. Red's not made with anything. Red is just red, same with blue.
Yeah, and so is green. Red, green, blue. It's literally the three primary colours.
Mix two colours and make red.
Correct. You cannot mix two colours on the computer to make green.
Yes, you can.
No, you can't. This is why it's called RGB on the computer. It's literally red, green, blue, and how we define the colors. I don't understand it. This is my problem, because it's literally saying that blue contributes only 11% of visibility of the light. I can tell you when I look at blue, it's much brighter to me than red. So yeah. I mean, we just have to assume that these numbers are right. I just don't understand how we get to those numbers. And there's also the part where the atmosphere didn't used to have as much oxygen as it has now, or actually it had more oxygen than it has now. And so, eyes had to change in that regard as well. Over evolution, I understand all that. Just these numbers make no inherent sense to me, because the article it refers to, it it makes no sense to me. This is talking about TV signals, talking about analog to digital conversion, but it's not explaining where this perception comes from. So yeah, but we just have to assume those numbers to be correct. It's what it is. But essentially, what this formula is saying, if I understand this right, is that to get to a grayscale color value, you take 29.9% of red, 58.7% of green, and 11.4% of blue. Weigh that those colors against that. Yeah, no, I understand the biology part. Just something doesn't quite connect, but it's fine. It's fine. Now we need to actually go and implement this shader. I think the first thing we want to maybe do is make sure the shader actually compiles. Okay. What I would like to do is we open the MGCB editor for Monogame assets. It's literally just the fact of, if we look at this shader, right? We're basically making a shader that turns a color picture into a grayscale image, and it's basically doing this thing here where the grayscale is a dot product of the red, green, and blue components. Red times 0.3, green times 0.59, and blue times 11. And then it says here that those weights are based on how the human eye perceives brightness in different colors. And saying green appears brighter to us than red, which is apparently brighter than blue. Now, for me personally, that is not the case. For me, blue is always brighter than red. Like it's more obvious, but that's obviously my color vision or my color deficiency coming in. But how we arrive at those numbers, I have no idea, because it's saying here the weighted values themselves are based on the formula that represents the luma component from this standard, which is commonly used for converting images to grayscale based on human perception. But when you look at this standard, it talks literally about analog to digital conversion. You know, I don't understand how we got to these specific numbers. Except for what we ripped out a human eye and counted the actual red, green, and blue cells. It's the only way, like, that I can see us knowing these exact numbers. You would literally take the cones and count them. How many blue cones, how many red cones, and how many green cones. Or I think they're actually yellow in our eyes, but different issue altogether. Yeah, there seems to be some mathing involved that just, oh, I think what I find also frustrating is that it's talking about this article and talking about, Luma component and how this somehow makes grayscale, but there seems to be a bit of information missing for me. Yeah, probably. Um, but anyways, we are now needing to make sure that the shader actually compiles. Did we have add an existing folder, please, which is effects. There's our grayscale effect. Let's go and clean the project and then let's build it. This is the thing that it needs to work. If this don't work, then we're dead in the water. Now, this has a red cross. However, if we actually look at A 12 succeeded, 0 failed, more importantly, these are actually just warnings. Right, and literally what's happening here is it's trying to open a screen in a almost virtual environment, and it obviously can't, but it doesn't need to. It really doesn't need to. I think we should end up with an actual compiled effect. Shall we maybe just check? And there we go. We have an actual in bin, right? We have this thing here, and just open it, and yeah, this looks like a compiled version of our shader. Has a bunch of extra meta information here at the top, but it looks like what I would imagine it should look like. Then where is our game stage? Up. Here's game state. Right. Basically, what we're doing now is we add the effect, load the effect, and then set it when we toggle pause or on game over. If state is not playing, then saturation is max between 0 and saturation minus fade speed. Okay.
Okay.
And then here's the draw method, which should actually be doing our effects. Yes. And that should actually be all there is to it. This is actually not terrible. Cool. So let's start. Game stage. Are you kidding me already? Fuck. uh, private effect, and we'll call this the grayscale effect. I always seem to think it's a capital S for that, but it's not. We're making a float, which is the saturation, which we are setting to 1.0 F, so like fully saturated, and then private const float fade speed being equal to 0.02 F. Okay. Yes, I know it's unused. It's fine. Don't worry about it. You should actually have the same problem with yes. Just ignore that. Gonna make these nullables so they're not complaining to me, right? Because we are initializing them properly at some point. I know that. Same with the UI here. Like boom. What's your problem? You want some documentation? We can do that. Initialize the game scene. Boom. That's all it needs to really do here. This may be a possible null value, so we'll do this. Just want to get rid of those warnings if we can. Load content from the asset pipeline. Oh. From the... What are you doing? The asset pipeline. Thank you. Jeez. Anything else? Some more nullables and missing comments. Game scene update between frames. And then it is time for my break, as my lovely wife just pointed out. That should do. More nullable issues here. Let's go and do like so. The game scene draw call young frame update. Right. Then we have the tile map, the slime, and the bat. All possible nulls, but they're not going to be. We're trusting the process here. Anyways, guys, if you like this sort of content and you want to see more of it, give me a like, a follow, a subscribe. It's always well appreciated. I will take now a quick 3 to 5 minute break. Game scene class don't know at the moment. But yes, with that, I will be back very, very soon, and we shall continue our journey into more game development and just having fun with this. Anyways, guys, I will be back very soon. See you all. And with that, I am back. So, where we at? Where we at? We are, let's have a look here. We are doing the grayscale effects and all that. Yes, we have added our properties that we need, or variables, whatever. And now we need to update load content. Load content, right? Where we just load the grayscale effect essentially down here. Grayscale effect equals content dot load, I imagine, right? Of type effect. Effects. Oh, we do need to quote that. Effects. That's it. So that's actually cool. I've just noticed there that Visual Studio Code is actually aware of the assets in the pipeline. It auto-completed that. We'd never typed this out, ever. Literally, it's literally aware of what the contents of that pipeline are. That's actually cool, by the way. Just something I noticed there maybe for the first time properly. Now we need to go and say in toggle pause that we need to set our yeah, let's go and find the function. If we're game state paused, we set saturation to be equal to 1.0 f. Set the grayscale effect, yeah. Set the grayscale effect saturation to 1. No, to full saturation, let's call it that. And then the game over method needs to basically do the same thing. Let's just copy that. And then we we modify the update method. UI update game time, and then if the game is in a state game over state, this actually gets replaced, this entire block here. Right, what we're saying here is if state is not equal to game state dot playing, if we're not playing, okay, then we let's just go and grab this comment here for a second, right, and say that saturation equals to math.max 0.0 f and saturation time minus fade speed. Okay. If it's a game over state, simply return. Wait. I'm doing this one. If state equals, right? Yeah. Game state dot game over. Do a return. That is apparently it for that. And then in the draw method, where was it? Load content. Wait, I'm being an idiot because we can just. You can normally search for things like you can. Ah, here. Where's my draw? Thank you. So, core graphics device, and then the tile map comes next. So this gets replaced. Right, we're going to say that if state is not equal to game state dot playing, if we're not in a playing state, we grayscale effect dot parameters saturation set value of our saturation that we've calculated. Just don't care about that. For dot sprite batch begin sampler state is sampler state dot point clamp, and effect is gray scale effect, right? Else we just draw. Also with a point clamp, but no effect applied. Right. So quite important to note, by the way, that we need to do this parameter setting every single time because the what's it called? Because the shaders themselves are stateless. The shaders don't remain or retain any information about their own state at all. Like that's just a thing. And here is the saturation thing. Okay. So this is how we're setting it from the outside. Understood. So I think this is actually it. Like everything is compiled in terms of the shader. I just need to see now if we can make run. Okay. So let's start and pause. And indeed, that's grayscale. Let's turn that down a bit. And game over also makes the game field grayscale. I love it. So basically that completes that part of the tutorial, right? So basically we can't have multiple effects applied. We would have to redraw the same thing with one effect and then the other effect. If you want to be selective and only have the effect applied to some sprites and not others, you will still need to use multiple sprite batch, sprite blocks, sprite batch end blocks. Sorry. Same, it's the same thing, really, because what you're saying is even no effect is essentially an effect. So you can actually change the effect in between. Yeah. Basically, what's going to happen here is, even though we're setting a parameter here of 1.0f, the minute we change this value, this is actually the value that's going to be retained for the entirety of this draw call, because the variable only gets evaluated and filled in when the sprite batch end call comes in. Interesting, okay. From this step, we learned that when using sprite sort mode immediate, that when a draw call is made, it is immediately flushed to the GPU and rendered to the screen, ignoring batching. This means that if you're using sprite sort mode immediate, then changing parameters between draw calls will apply the parameter change after it is made for the next draw call, which makes sense, yeah. But okay, we've made shaders. Cool. I guess. Hmm. Be interesting to see if we could do some sort of other effect. I mean, if we look at one of these effects, we could probably do something different. Hmm. Actually, I want to understand. Let's go and do a bit of code sorting, formatting, I should say. I mean, this part is easy enough. This understand. It's in the update call. If we're not playing, oh, right. So either game over or paused will both have the saturation applied. Okay. Why do we need a return here? I don't. Right, actually, yeah, this makes sense because in a game over state, we shouldn't be applying any more updates. We shouldn't care about slime, bat position, collision checks, none of that. None of this should be applying. Yeah. Same here, where we're basically returning sort of early because we're paused, we're not doing these updates. Yeah, okay. I would like to still see if we can maybe. What would a pixel shader look like? And not a pixel shader, a vertex shader. Like, is that a thing? New item. That was a sprite effect that we added, right? What if I just say normal effect? I don't even directly know what effect to apply or what we want to call it. We'll just call it test effect. Right. And go and build the whole thing. And okay. Build successfully though, that's all I care about. And here's the test effect. So Vertex shader input, vertex shader output. And again, we have the sort of same thing here where we have the main shader. Yeah, I don't think I want the pixel shader applied here.
Yeah.
Or we could combine. We could combine those. Ooh. Maybe grayscale effect. And main pixel shader. Where's the main pixel shader? Here. And here's the vertex shader. So what would I want to do with this? Output position is a multiplication of input position plus worldview projection. This is probably going to break something really badly, but that may just be exactly what we want for testing purposes, for just seeing what happens, right? We will need a few more things. We will need just the saturation that we actually need. We have the vertex shader input, sprite texture sampler. I don't see you at the moment. We'll need to add that. Okay. And that's before the vertex shader output. So something like this. Right, anything else I need to... Nope, the rest is fine. Okay, so here's our two passes, the vertex shader, then the pixel shader compilation. And then for now, I figure we're gonna just need to load in the other effect and see what happens. Probably even do it slightly smarter and say we'll make another effect, which we'll call test effect. And initialize is fine. Initialize new game, don't do anything for us. Load content is where we need to be active the first time, so the test effect equals effects test effect. Then saturation is still the same, and we just need to just finding now the calls into our effect. Yeah, drop. We'll do the test effect instead and see if it does anything for our vertex shader. See here, make run, see what happens. Right. Oh, we had a bad error. Something I messed up. So these are issues with the actual effect. Textity, no matching two parameters, parameter intrinsic function. Uh, this is weird. So you're saying that text 2D is right. The sampler. Wait, no. Do we have the sprite texture sampler here? Yeah. So you can call text2D with sampler2D and then flow2 have to, what was it we're actually calling it with a texture coordinates. Hmm. Did we? No, this all looks fine to me from our effect. Wait a minute, I don't think I have this.
Watch take time.
Sprite texture. Which we don't, that makes sense. Okay, I think that was it. Missing a variable. I'm gonna go and stick the kettle on. I need some more brew.
Oh, careful.
Yeah, dog was in the way. Wait. And I am back. And we have another error, of course. We have more errors, of course. So what happened? Yeah, still the same problem. You still don't like the call to text 2D. Um, Invalid subscript texture coordinates. So sorry, what was your texture coordinate is your issue? Um, Input is a hmm. Can we look at that again? Where is my actual shader? Da, 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 da. Uh, Interesting. I I think we're not allowed to do vertex shader and sprite shader, pixel shader at the same time, but that makes no sense. We have the effect here. Hmm. Technique. Oh, wait a minute. Wait a minute. Right, 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 right. Right. Um, wow. Let's just undo a bunch of stuff here. Because this is a different technique that's been called. I think that's what we're running into here. I mean, we can just test the effect out for now and see what happens. Um, Resist near color. Can we maybe change this color here? Output color is equals to input color, so why don't we try do something like this, actually calculating the color here. And there's no color itself. We need to go and say input dot color RGB, right? And then the grayscale color is that. That also makes sense. And then the final color is lerped. And it's input color, input dot color RGB, and final color. That's the final color for it. Like, we should still get a grayscale effect. Maybe. Maybe I just broke things horrifically. We will see. This is more of experimentation now, trying to understand the different systems and how they all come together. We'll see. And no matching. So we can't even do lerps in this way here. Wow. Lerp between float, float, float. So 3 equal types you need. Thank you. But you say you have no intrinsic 3-parameter function, even though you say one of your intrinsic functions is lerp with a float, another float, and a third float. Hmm. Seems silly for you to say I can't do this when in fact you're telling me I'm supposed to do exactly that. You're not even telling me about lerp, Pyong. Okay, fine, fine. And there's no Okay, so this ain't working, and we're gonna need to say output color is equal to input color is equal. Well, output color equals to input dot color. For now, I don't know how else to do this. First off, are you going to compile now? That's the first big question. Something maybe? Yes. Okay, we're working again, and I imagine we. Yeah, the shader is not working at all. Wow. Well, yeah, I guess that makes sense because I don't even know what this shader actually does. This particular vertex shader. It, it's almost like we could maybe. There's the sprite patch end. Oh God, that's not even like we can easily do both effects here. Ah, fuck it. Okay, it was a nice little experiment. Get me this guy and exclude it from the project, rebuild the entire thing, thank you. Come on. Perfect. Let's then say we can't need. Where's there's a few places where I need to go and just remove this now A here. We don't need that test effect loaded, and we do not need it here defined either. So there we go. Close you. Delete the actual FX file, and we should be back in the same state that we were before, I believe. Let's see. Yes, turn the sounds down a bit, start, pause, and there's our grayscale. Fantastic. Good. I would like to see maybe if we can upgrade the text on the main screen because I'm not happy with it saying the wrong game title. So let's have a look at this. Game scene, is that even? That's not right. Is it? No, it's not. It's title scene that we need to look at. Although, yeah, no, that should. Did that actually display right? I can't remember. It must have. Yeah, okay, yeah, that was me just not thinking right. Cool. I guess the first thing we're going to do right now is commit all these changes. That's just a bit of change there, and here's the effect applied, some documentation added. Yep, more grayscale effect. Seems fine, and this is just adding the effect into the content pipeline. Okay, cool. So let's say this is chapter 24 done. Added grayscale effect to pause and game over screens. Implemented as pixel shader. Jesus, I can type, honestly. That's all that's really to it. Commit and push. Yes, please. Publish that out. Okay. I imagine if we now go and check. Yeah. I have a new pull request we can open for against chapter 24 and say, yes, this is a new chapter, a new pull request. Create a merge commit. Indeed. Do not delete the branch. Now we're packaging the game for distribution. So what are we doing here? We're doing sort of self-contained deployments. And this means that this basically packages all the .NET dependencies into the game, but yeah, make sure that people can just play it. So let's go through this. We're preparing the game for release. Final testing. Linux, building for Linux.NET publish C release. That's the runtime. And then here's okay. We can add this actually into our make script, into our make file. Let me. Let's go and close a bunch of this stuff down a bit, and yeah, make file. So I would basically want a new target called publish. Yeah, that's just making a release build. Okay. So we'll say publish does a release build. Okay. But we also need a few flags up here, so let's copy this and say this is the publish flags, right? Which are thusly. Let me go and self-contained is already in there. The runtime should already be there, so we literally just need to add these two. I'll probably need it here as well for the publish step, right? Yeah, should be able to basically say dot net publish what's the release flags? So it turns out I don't need this, right? We just need the release flags and the publish flags. Release flags and the publish flags both need to be appended here. Release config. Uh, runtime is coming from these two parameters. Linux build, that's what I'm going to need here as well. Release flags, publish flags. Right. Nope. And then we have a similar thing. I need to go and copy and say this is publish win, right? Or win publish. Well, this is how we did this. So this is then going to be win-release. .NET publish the win build parameters and the release flags and the publish flags, right? I think. Shoot. Git stash. Take all those changes, stash them for a second. Git check out. Excuse me. Check out main. Git check out. Oh, bless you. Check out with a new branch called chapter 25. Yeah, git stash pop. And we have a modified make file, which means if I now say make publish, see what happens. Okay, so you've done a build. Okay, let's quickly check in Midnight Commander, makes it a bit easier to just navigate. Go to Slime Dodger. I feel like it was bin release, and there's the publish directory, which essentially holds our entire game installation. Literally, there's our executable for the Slime Dodger. Here is the novice game library, our DLL for our actual core library, and well, this is the actual executable for Slime Dodger. The actual executable that you see is actually just a wrapper to run the DLL file, essentially. But it's a DLL file that contains your actual code. And yeah, you're just adding essentially all the .NET things that are needed to make this run, from what I'm seeing here. It's fairly big. But the fun thing is we could... Ooh, we have a Windows machine. We have a Windows machine. Shall we do a little bit of a test? Go and open this, please. I can close this window. Let me change...
This boy.
Let me change how we're mounting or where we're mounting. Something like that. Workspace. Let's make this a bit bigger, and then I'm thinking what we're going to do is make Win publish, right?
Give me five.
Just make a Windows execute. Oh, that doesn't look right. These are Linux build parameters. So they're clean and that is not quite working quite right.
You got the sneezes.
Well, we'll look at that in a minute, okay? Not all that important. That's literally just a bit of what's it called? That's me just needing to clean up a bit of make file. That's not I'm not too worried about that. Can we please have a Windows machine? I knew there was a reason why I changed over to Linux for good. Come on. Can we check is performance, how my performance is doing? We're okay. Yeah, we're good. Oh, wait a minute. I think we're using too much RAM. How much RAM did I give you? It's only 8 gigs, that should be fine. Anyways, oh, this is slow. Hello, computer? Hello, computer? Let's have a look. If we open up Explorer, bless you.
So,
Geez, this is running a lot slower than I expected it to. Uh, I should see a mount here. Ah, perfect. Open. Learning Monogame. Slime Dodger bin release. Win x64. Where's the publish directory? And copy all of this right over to say here. And there is our entire game install. And where there's Slime Dodger. Let's go and run it and see what happens. We may not have any luck because of missing graphics acceleration. Unhandled exception. I had a feeling. Two possibilities. Either you're missing .NET, which would be weird. For the love of... give me a terminal, please. Need to see the actual exception. I figure it's to do with lack of graphic support because it's a virtual machine. And I'm not doing any GPU pass through Oops, that's not going to work. And why? Odd. Oh god, that's the wrong keyboard setting. Come on. See what happens when we just try and run it. Yeah, that's exactly why I imagined this, yeah. Fail to create graphics device, we just don't have the ability to just say, hey, make a graphics device on virtual machines. You can, but that's way outside the scope of what we're doing here. It, it's actually frustrating. It would be cool to see it, but yeah, it requires some sort of frame buffer, to actually do do proper graphics on. Oh well, that's a shame. I could test it on my wife's machine. But again, that's sort of outside of the scope of what we're doing here. What I will do for now is quickly tear this machine down, and it is, as my wife just mentioned to me, it is my break time yet again. um, so I think what I would like to do. So where's Win Restore? Right. We should have another. There's Clean.
Stop.
Clean also depends on the build runtime. So we would need to make a win clean. Basically copy all this. Oh no, we have a win clean. It's just not done right. Win build runtime debug config .NET clean win build runtime. All this is fine. It's this part I was missing. Right. And we were basically calling the wrong clean function, and I will also need to do a win restore, because then that is the win build runtime for the restore, which win restore. Oh, wait, that's me doubled up. Here's win clean. Realistically, I feel like these guys actually need to live up here. Clean first, then the restore, and everything that builds on top of that. Right, I think that would work better now. So if I said make win publish, I just want to quickly see. Yes. Yes, now we're cleaning up properly. Good. Cool. Make win clean. Right, and then make release, for example. And then I think after the break, what we're going to do is work on the makefile a little bit more and make it so that the publish maybe ends up in the directory right here in the root somewhere. And just sort of go through somewhat of the tutorial, understand some of that stuff a bit more. Anyways, guys, if you like this sort of content, give me a like, a follow, a subscribe. It's always well appreciated. And with that, I shan't be long. And with that, I am back. Yes. We're good. Um, basically, this is exactly what we're basically working through right now, the building for different operating systems. Uh, yeah, okay. Uh, so you basically need me to make that executable, which already is, right? I know for a fact that works fine, and then you would just tar it up. Um, yeah, tar it as a gzip, basically, tar gz. Um, the entire directory. That's one way of doing it, probably. And so just to explain this a little bit, what was a tar, was a gz. So a tar is essentially an archive of a directory without any actual compression applied. It's literally just you take the directory contents and then you make a single file with all the files inside and the directory structure. The .gz at the end then means we take that tar file and we gzip it, or we compress it together with a compressor. It doesn't matter actually whether we use RAR or gzip or whatever. Um, okay, so here is publishing parameters. Ready to run is a feature in .NET that precompiles code to improve startup time. This sounds like a good thing on paper. However, for games, it can lead to micro stutters during gameplay. This happens because ready-to-run compiled code is initially of lower quality, and the just-in-time compiler will trigger periodically to optimize the code further. These optimization passes can cause visible stutters in the game. For games, it is recommended to disable ready-to-run by setting publish ready-to-run false in your publish command, which we've already included in the example. Is that true? Let's check our release flags, and yes, publish ready to run is false, and then the tiered compilation was that. It's another .NET feature that works similar to ready to run. It initially compiles code quickly at a lower optimization level, then recompiles frequently used methods with higher optimization. While this improves for application startup time, it can also cause stutters during gameplay as methods are recompiled. It is recommended to disable tiered compilation by setting that to false in your publish command, which we have already done in the example. Okay. Native ahead of time compilation. Compiles your entire application to native code at build time, eliminating the need for just-in-time compilation during runtime. This can provide better performance and smaller distribution size. However, AOT has limitations. There is no support for runtime reflection, no runtime code generation, and some third-party libraries your game uses may not be compatible. For monogame game, maybe should have been an A in there for a monogame game. AOT can work well if you avoid these limitations. Okay. And then we could also be doing trimming. So let's maybe do publish AOT true. Well, we'll set that. Okay. That is a publish flag. What else do we have? Trimming. Trimming is specified with p-trimming true. Removes unused code from your distribution to reduce size. It is automatically enabled when using AOT. While trimming can significantly reduce your game size, it may remove types that appear unused but are accessed indirectly through reflection or generics, causing runtime errors. I don't think we have such an issue. Like I don't see us having done anything fancy there. Let's actually look at an example of trimming. Well, let's make a new console quickly. We'll go into workspace, repos. Let me quickly, where's it? Hello assembly, I think. That's what I wanted to look at. And so we have this C program, right? If we go and check quickly hello.c, it's literally just a printf with a return code, and it made an executable called hello. We can take that executable. Apparently I cannot. Oh, it's called strip, I think, in Linux, right? Strip. Hello. And now the file is a little bit smaller, right? It used to be 15,968 bytes, and now it is 14,472 bytes. So something got removed. And this is essentially what trimming or stripping does. It removes any sort of extra information from the file, and we can just leave that enabled since we're assuming AOT ahead of time compilation to be true. Cool. Trimming can cause issues with content pipeline extensions that are used at runtime. When the compiler cannot detect that certain types are used, pardon me, especially with reflection or generic collections, they might be trimmed away, resulting in type not found exceptions when loading content. Where if you encounter runtime exceptions about missing types when loading content with trimming enabled, you can resolve this by ensuring the compiler recognizes the types by being used at runtime by making the following call. Content type reader manager add type creator type of reflective reader reader type full name new of that reader type is the content type reader of the content pipeline extensions we reserved. I don't think we need to do this. Like I don't see an issue here in this regard because we're not using any extensions of the content pipeline. We're just using built-in things. Single file publishing packages your entire application into a single executable. Whilst this sounds convenient, it is essentially a self-extracting archive that extracts to a temporary directory at runtime, and this can significantly increase startup time for larger games and may fail on system with restricted permissions or limited storage. Yeah, we're not going to use that. It's really not something we want to be considering even. Different operating system use different path separators. Windows uses backslash and so forth. Path combined in your code rather than hard coding path separators. This is something we do need to address, I feel. This is something we need to address because yeah, because I feel like we're loading in Atlas definitions and that directly from file system. So where would that be? First off, let's go and save this as a change, and why don't I just look for this string? Sure, there is a thing where I can say, hey, find me. No. Edit. Why am I not getting that at the menu up here? My VS Code is doing things. Yes, I know the guest is not running. Quit. Code in this directory, please. Yeah, there we go. Find. And I want you to find it everywhere. Is this a thing? There's a way of doing this. Well, is it in here? I can do that. Maybe find in folder. That's what I want. Yes. Find in folder. That. Okay. Okay. Yeah, we have a few references. And they're all called, it's all this from file. Okay. Don't need to worry about that. As a stats file, don't care. File list, don't care. Ah, here we go. Here we go. Here we go. From file, yes, but this would not work. So we'll make a new string file path being essentially composed out of these two strings images and atlas definition XML core content comma file path. What's it called? Path combine. Right. Yes. And then we need to do that again, and basically what we're going to say here, once we've loaded that, we'll make file path equal now to path.combine out of, again, two strings, one being images, that's easy enough, and the other one is tile map definition XML. Gonna chuck that in there and say file path. There we go. It's not null here, it's not meant to be. Oh, that's because I forgot a semicolon there. Yes. That's just normal content loading, so I don't need to worry about that. Here, same problem. So we'll make a quick string file path being path dot combine out of two strings. Something like so. File path. Right. Combine. And then we have one more from file, which again, we're going to just do exactly the same thing here. We'll make a string called file path, meaning it's actually coming from path.combine with two strings as input. One of those strings being images and the other being atlas definition XML, and say we're loading file path like so. And I think that's it. So that's basically us fix that. Question, no, this is fine, right? From file is where the content lives, and this is the actual file name. Yeah. Can we make release, I guess, it doesn't really matter. As long as we can compile it. Looks like it compiled. Okay, let's get rid of all these warnings actually. Like, whoa, this is a lot. So let's start in game scene UI. Yes, I want that, but I want to see this. So you want a comment holds the game scene object. Let's make these nullables, or at least ignore the nullable property. A bunch of them. You need a comment. Initialize the game scene UI. Something like this. Nullability here. Just ignore all that and assume we're good. Okay. Missing XML comment. Load assets from Jesus, again with that replacement. Don't do that. From content pipeline. This is in game scene, so this is a game scene update between frames. And then more null value issues. We're just going to have to assume these are going to be not null, right? Because otherwise we've obviously really messed up in our program if they ended up being null in these conditions. Draw call needs a XML comment. Game scene draw call during frame updates. Something like that. Yeah, ding, 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 ding. Geez, let's do like so. And not getting there, okay. Just assume these two are not null, okay? Just you're fine, honestly. I would love to see you fix this for everything, but I don't see it. Okay. Right. Let's just again assume none of these are going to be null. Or we broke shit badly. Right. Damn it. Didn't mean to delete that. I'm just meaning to have a exclamation mark at the end there. Game scene UI object. Just that's all it really does. You also resume button, retry button. Adding the required modifier or declaring a field as nullable. So resume button, make that nullable, make retry button nullable, resume button click. So we'll make these possible null values, even though that can't be a thing. Game scene UI constructor. And then this and this. Okay. Let's go and do another. Yeah, make release even. Don't really matter. Okay. And we still have a few warnings, but it's less than before. So with slime segment, option slider, it's fine, it's fine, it's fine. Slime segment has, of course, we're missing a segment, a segment of the slime, something like that. Segments must contain a null value, must contain a non-null value. Input buffer and body collision. Also an event handler there. There. Again, input buffer, segments, something like this, and then there's a missing XML comment. Reverse direction of travel upon bounce. No, just reverse direction. Okay. What else did you complain about? Slime segment options slider. Nope. Text instance may or may not be empty. No, is that not the problem here? It's the actual text that may be. Okay. Oh, give me death. So that was option slider. Then we have animated button. Also needing a little bit of cleanup and a nullability check there. And the actual slime has also some issues. Does it though? I don't see it. Okay, let's go and just clean up my top bar a little bit here. Let's do another make. So we had 11 warnings. We had before that we had 46 warnings, so we've definitely worn that down, and now we have only one warning left, which is in the actual slime.js. So here you have a dereference of a possible null value, which just say that the content loader is not going to do that, okay? We trust it. Oh. Or me death. Okay, build succeeded and no warnings. Cool. Let's keep going through this. So we've now fixed the file paths consideration, right? So they are now multi-platform or cross-platform compatible. Every single one of these names that I have typed is case sensitive. Like Windows doesn't actually care whether you use uppercase and lowercase names in your file name, it will just find it. Linux and Mac, however, they care very much. So Atlas with a capital A is a different file than Atlas with a lowercase a. Whereas in Windows, you couldn't even create a file called atlas.png, even with different spelling, like different casings, if a file like that already exists. Um, we don't have external dependencies at the moment, but if we did, we obviously needed to make sure that was a thing, yes. It is important to understand the practical limitations and trade-offs involved in various security approaches. Okay, so the content pipeline compiles assets into a compressed XNB format, which provides a basic level of protection for your game content. For the majority of indie game projects, this compression is sufficient protection for several reasons. XNB files are not standard formats, unlike raw images or audio files. XNB files require specific knowledge and tools to extract. While the XNB format is documented and part of the Monogame open source code, this still creates a barrier for the casual user. While not cryptographically secure, important to note, XMP compression deters casual attempts at asset extraction. The primary purpose of XMP compilation is optimization, with content protection being a secondary benefit. And the same format works across all platforms without additional configuration. That's cool. Yeah, you could do code obfuscation. This is one of the big things. Obfuscated code often runs slower than clean optimized code, because you're just adding a lot more indirection, a lot more like extra method calls to just sort of detract or yeah, what would you call it? Distract from the fact that you're running a certain function. Stack trees has become unreadable. Yeah, I don't think we need to worry about code obfuscation, and the harsh reality of it is proper reverse engineer basically won't have a problem at all going through obfuscated code. It really isn't all that terrible. Yeah, and no security measure is truly impenetrable. It really isn't. It's as simple as that. Um, okay, so they have actually made bundles or tools that make this bundling easier. Game Bundle is a net command line tool created by LPEG, simplifies packaging monogame and other net applications into several distributable formats. This tool can automatically bundle your game for Windows, Linux, and macOS platforms, create application bundles for macOS, and handle various packaging configurations with a single command. Interesting. And Monopack is a net command line tool created by Shyfox Studio, specifically for monogame projects. According to its documentation, Monopack is a .NET tool used for monogame projects to package the game for Windows, Linux, and macOS. Could look at it if we wanted to. Uh, we could have a look at one of those, just for maybe understanding how one would do such things. So first you do an install of the tool. You'd probably even do this as a global install, right? And then the project packer. So you literally just run it as an extra command. Project, where it's going, which runtime identifier to use, or a number of RIDs. That's actually cool. So you could basically build the entirety in like one step. Hmm. I mean, we couldn't do macOS stuff anyways, realistically. But it could be interesting to see this packaging step. Uh, that's one way of doing it. Let's look at the other one, game bundle. I want to almost say monopack seems straightforward, and we could just implement it in our makefile as an extra step. Um, Again, you just install it as a tool, as a global tool, even. It goes to bin bundle to build and bundle your app for Windows, Mac, and Linux and Mac. You always run the following command from the directory contains your project file, game bundle WLM. So Windows, Linux, Mac. Ooh, I like this a lot more actually. Because there's one thing that's doing that I haven't seen the monopack do. It cleans up output directory using NetBeauty, which just another piece of software, NetBeauty 2, by moving most of the libraries into a lib subdirectory. That actually is, I like that. I like that a lot. Fuck it. Let's go and do this, right? Let's go here. .NET tool install global. Yep, global game bundle. Right, it's been installed. So usually we would want to run it from the CS project. Sorry, we would want to run this inside the directory where the CS project file is. But I think we can just do this slightly different and say, hey, we'll pass the parameter in. So give me a make file, and we'll make a hack step, and we will call release and win release. Right, we need the two releases build first. And then tab, we say game bundle, source, right? The source being app name, right? Or we could just actually grab the project. Yeah, the actual location. Oh, so that's what we'll pass in. Project. WL. We're not building for Mac. Output goes into. We'll just put it in here for now. Or probably better off doing this because .NET publish help. I want to have it output its stuff into a different directory. So this is a -o as well. Something like this. Right, I want your published build in there. I think we need to do this just to make sure we're not mixing them up in the same directory. And you're outputting your package thing into -pack. The geez, good. There's quite a few parameters here that I want to be using. So I'll put this pack. Interesting. I'm not. Huh. So I'm confused a little bit because the documentation talks here about storing the build results in zip files instead of folders. But we're packing, I thought. Right. Anyways, I do want to use nbut2, so let's go and add that parameter. Although beautifying instead of netcore beauty, like I don't know if this is actually required. Let's just not do this for a second, right? And just see what the result is going to be. No, we definitely don't want to exclude anything. Lib name, trim the application when publishing. Yes. Yes, absolutely. Trim it. Do not do an ahead of time compilation. If I remember right, we didn't want that. Yeah, no, we do. So T, capital A. Build arguments, name builds, name the build output directories by the name of the executable. No, I think that's it. I think this should do. I think this could be a start at least for a make pack. Oh schnitzel. What happened? .NET clean. It doesn't have a target for .NET Windows run. Don't have a target for .NET Win x64. Ensure that restore has run and that you have included .NET, not .NET 9 in the target frameworks for your project. We did. What's I guess you wouldn't even need to run these because I think you would do this yourself. Let's see. And failed with an error. Native publish targets cross OS native compilation is not supported. Right. Basically what you're saying, if I understand this right, we can't do this. We can't do ahead of time compilation in this situation. Make pack. See how this now comes together. This should work. Should being the operative word. I think you've bundled for Windows from what I'm seeing. I don't think you like me trimming these, but fair. Let's have a look. Let's have a look at this entire Scheißendreck. So here's Pack Linux. This is definitely a lot more easy to understand and look at. Like, there's literally just our actual game living here in the main directory, and the rest is here in lib. So I guess the question is, does this still run? Ooh. Okay. Okay. This is the warnings we were getting. We shouldn't be trimming the monogame, or the. It's not so much monogame that's the problem. It's the gum UI thing. So RMRF pack and make a new package or game bundle. But I think a .z would be cool, so we could just zip it up instead of having it in another directory like this. Probably what I would want to do then. It's a run, and there we go. Game runs. Sweet. RMRF pack again one more time, and then add a dash z here for zipping it. I believe. Yep, Z for zip. And where was let's try and use NBUT2 or NBUT2 instead. Make a package again. Okay. We should now expect to see two zip files in this directory, right? So if I look at pat, jeez, you didn't even do that. Are you sure? What did you do? Restore complete. You say you'd done the thing, but ls la. Oh, there's the zip files there, right there. Why did I not see them? Yeah. Oh, right. It's a visibility issue of colors, but yeah, here's our executables, or sorry, our game content, and hurrah! That's cool. It's easier distributable, I guess. We would probably tell git ignore as well. I don't version control that directory, so pp big P and small p pp nope back. Like so. Make pack. And the only changes I see here are pertinent to us. Okay, cool. So let's say this is chapter 25 basically done, right? Added packaging step. Into makefile. This is still all makefile driven. We also made paths cross platform form compatible. Right. And we'll call it fixed in quotation marks. Fixed all nullable warnings. That's basically what we did here, right? Commit. So, what else? And then we could publish the game to HIO, which I'm not going to do, right? There's probably so many clones of this on HIO already. It's just not contribute to that. That's just spamming, in my opinion. And then you say conclusion and next steps. So what have I learned? We've learned how to make a game. We learned about graphics and rendering, about game systems, production, distribution, advanced topics. Now this is maybe quite cool. Like there's a collection of focus tutorials on specific monogame topics. Depending on what we would want to learn, maybe this could be interesting. Uh, Look at this. First shader, infinite background shader, a batcher. Ooh, I like these sort of things. So this is actually this is an effect shader. We could use this. I'm not even kidding. Like this is stuff we've done before. All right. So this is a draw method where what? Wow, we're doing things different though with this matrix thing, matrix projection. You okay? That's going into our shader. So this is literally just the image that we're creating. What does the shader do? So what's the first one? The vertex shader is coming first. It basically says that the pixel input is equal to the output. No, you're making a variable called output of type pixel input, and the output position is v position and v projection. So that's the vertex that we're looking at, and then the view projection of that. Wow. I think the interesting part is actually the sprite shader, or the pixel shader, sorry. Because what is it doing? It's doing a diffuse. Diffuse meaning it's the texture, samples to the texture coordinate, and then returns that value times the pixel color value. Okay, this is maybe what we view as a 4x4 matrix. This matrix is used to convert from world coordinates to view coordinates. Here's an example of those coordinates for a window that has dimensions of 1000 pixels by 500 pixels. How is this 4x4? I I don't. Right now, this one is set to the identity matrix, which means that it takes the world coordinate as is. You can have a bit of fun if you give it a value. Matrix creates scale. What? You know what? We'll try and make this happen. Like, I feel like this is something we can add. Right, I'm just sort of looking through what other examples he has here, and maybe we can learn a bit more about shading. Do we actually? Yeah, so you stretch it. You take the background UVs, multiply them by the background's dimensions, so it ends up in a world. Wow. And this is how they tile it, okay? I think this is a little bit too far right now. Let's work on that first shader. Right, we have a shader here that we want to use. So let's maybe start with exactly that. Oh god, I didn't even give you my. Yeah, it's fine. Let's go and do that again. I forgot to give you my passphrase for my SSH key. And would you believe it? It is that time again. Jeez. So we actually what I'm going to do, we're going to take that break right now. I think that's might as well, right? Put you on this side maybe. Don't want to hear it, Patch. And yeah, we're gonna call it right here with a little break. So guys, if you like this sort of content and you want to see more of it, give me a like, a follow, a subscribe. I will be back in 3 to 5, and then we're gonna try and make this shader happen in our game. Right, even if we're not seeing any like big visible effects, I think it's more about the how do we actually make this work, right? And I don't pretend to even understand any of it just yet, but we'll get there. But with that, I shan't be long. And with that, I am back. So, we are making a new shader. Not that I understand any of it, but it's fine. Let me. Yes. We'll start off with the obvious. We make this happen in the content editor thing. What? Shouldn't you have the effects folder already imported? Uh, this is weird. Add an existing folder right there. Weird. But we're making a new item, which is a normal effect, and we'll call it first effect, or first shader even. Right. Oh, where is that shader? Don't need the library open. Content effects, first shader effects. So the beginning part is the same. Then we make a float for x4 called the view projection. Don't see you using that matrix. Then we have vertex input. I suppose we can just leave it vertex shader input. That's fine. Position is position 0, color is color 0, and apparently we also need a float 4 called x coord, being x coord 0. Did we need this as well as sampler called a texture sampler, which is register S0. Good grief. There we go. Then there's the vertex shader input, the vertex shader. What's the pixel input? What? So, well, let's rename these things and do it properly. So this is the pixel input. Which we basically set exactly the same, right? Okay. Um, sprite vertex shader, sprite pixel shader. So these are the main PSs that we're going to just replace. And say pixel input is the type sprite vertex shader. Takes a vertex input. Pixel input output, making a new variable there, output dot position equals not mul, not null, multiplication, not nullification, multiply v dot position by view projection. Sure. Oh. Output dot color equals the vertical. Right, output dot text chord is the vertex text chord, and then we just return that output. Okay. Yeah. Then the next one is returning a float 4 called the sprite pixel fader. That means we are actually going to say this is the sprite vertex shader. This is the sprite pixel shader that we're going to call here, right? Next, we say that float for diffuse equals to text to the texture sampler p dot. Oh yeah. We need a pixel input called p, and then that is p dot. Well, we could x coord dot xy for whatever reason. And then we are making another, no, we just return that, actually return diffuse times p dot color. Okay. And then here's our actual calls. Technique sprite batch. All right. Then we need to just load that shader effect. So let's go and save this. We will probably want to go and clean and compile. One failed, so that would be you. Sprite pixel shader function return value missing semantics. Ah, yay. So we didn't quite do it right. That's fine. Interesting, it doesn't have a P0 pass, it's just pass. Sprite pixel shader takes a pixel input. Oh, wait a minute, I forgot something here. SV target. Where is that coming from? Huh. Let's have a look if this compiles now. Come on. Okay, so the effect built this time. Good. Load the assets in game. So what I'm thinking is that we're going to apply this shader over the maybe the title scene. Just somewhere where we're not interfering with the game itself too much, okay? So let's go up here. We're gonna go and add a new effect. Private effect. We'll call this first effect, just because. We'll make it a nullable like so. Then I would basically just load that in. Where is we should have a load content. I'm almost positive. Initialize UI load content. There we go. Okay, here. First effect equals core content load, right? Core content load effect effect frustrator. Okay, with that we have loaded that effect, and then I just need the draw call, I think. Yes, sample state. Effect is first effect. And then sprite patch, and that should literally be it. This should literally be us making that happen on the title scene. Whatever it is this shader is doing, it somehow diffuses something. I don't know if we're gonna actually see a visible effect for that though. Let's make I forget all my make targets. I have quite a few, unfortunately. Probably not the best way of doing this, but what if I said, yeah, just make release, I guess. We just need to see if it builds, really. That's all I'm interested in. I don't need to see all the rest of it. Okay. But these warnings I sort of expect, right? This is literally just saying, hey, I'm trying to create a graphics device on a wine instance, so that's obviously not going to happen. But I think we can essentially ignore this and just for shits and giggles see if it runs. And I forget, it's going to do the entire rebuild. But fine. I'm just trying to think if that was even the expected result. I feel like that wasn't it. Uh, yeah. This is maybe not the best scene to do this on because there is stuff happening in the title scene that I'm not. Just a second. Which sample state are we? It's point clamp we're using. Oh. Maybe. Uh, right. No. There's something I forgot as well in the draw code. We need to actually pass in a bunch of values. Um, So basically we need to go and make ourselves a view matrix. And a projection matrix. This I could retrieve from. Oh God. There's God, where was that? I feel like we should have a property for that ourselves. As in core dot graphics device dot viewport width, right? And then we can do the same here for the height and literally just grab it out of our own instance of our game class. That is the prediction matrix. Then we need to give the shader parameters, which we're going to do here. It's first effect. Then we do the entire draw. This may or may not do. Let's see. Make run. Hey, it's different, right? So we have colored sort of playing field right now, and if I hit escape, we see that not going into gray. Why not? Did we break? Um, I don't. Oh God. I don't think we've pulled in the changes from our main branch. Oh shoot. Uh, Git fetch. Fuck. Git pull, I guess. See what happens. Unstage changes. Git status. What are we looking like? Okay, yeah, I can go and do a git stash. Git pull. But we're not. Did I ever? I feel like the build the pull request has been closed. Like it should be fine. Let me check slime dodger scenes game scene. There's the effect. So we have it on the main branch. And we do not have it in. Fuck. Can we git merge main? Hmm. Uh, it's merge that we should be doing, but git merge help. Merge how we the current branch is master, then git merge topic will replay the changes made on the topic branch since it diverged from master until its current commit on top of master and record the result in a new commit. I feel like this should have been it, but I don't see you having imported that effect. It's completely gone. Huh. Merge. Like, I'm not entirely sure what's going on here. Like, I made a mess somewhere in my Git. Right. Oh, I think I know what's happened. I didn't do the pull before we branched off, but I think if I go back into chapter 25 and do a git merge main, we should now have that information join us. Yeah, game scene has a conflict. Yeah, that's gonna be interesting. Resolve in the merge editor. What's going on? I like this actually more. Whoops. There we go. No, not all current changes. I just want to accept. Ah, yeah, accept current. That's what I want. Is that it? Ah. Um. 3 conflicts remaining. We want the incoming. Uh, this is the same thing. Except current. This seems all wrong. Load. This should be the right description there, that's fair. Next. That'll be you, actually. Next. And draw. Yeah, we'll just accept the current one there. I'll do incomplete the merge. Right. Git stash pop. Whoops. Your branches ahead. Good changes to be committed on merged path. Git add add slime why not? Slime dodger slash content content.mgcb, I believe, yes. What else? Git status. Okay. The title scene has our change in it. Okay, so we just need to git add the actual effect shader. So we can just say, hey, go and add this. Let's run it. Make run. See what happens this time. We should see both effects working. Maybe not. The command something something failed. What where? Exited with code 255. That's not entirely helpful. Build output. I feel like you're broken. Not no es bueno. What's your changes here? Ah, jeez. This is I need the actual content file. Find that. Viewed, but what? Yes, yes.
Come here. Come here.
Patch, go see mum. Babe, I was gonna take him in a bit. Um,
He almost lost his ball though. Went in the water and he went going after it. He went into it was near shore.
all right. So
Hey, have a drink.
this is fine. Let's see what's going on here. Clean, build. Oh, thank goodness. Okay, okay. So that'll build. And see if it builds. Like if it compiles the shit. So okay, yes, we have things in shaders. Like we have a shader now happening here. And our snake getting longer and longer, and if I hit escape, yes, our grayscale effect works. Sweet, so we now have two shader effects going on. 91 on the title scene, which, yeah, sure, it looks a little bit weird on what we're doing, but it does a thing. Like, we can just even run it again. Why don't I make pack? Is it? Oh wait, this is silly because it's just gonna create a zip file. So let's not rmrf. Let's just go away. Make one. Whoops. Excuse you. That makes no sense. Where's my make file? .NET 9. What are you complaining about? Did we fucker up the project files? No, that's a .NET 9. Where is... Yeah, confused.com. Yeah, library. Library is built against .NET 9 as well. Like, what the frig? Let's go and do a bit of a clean. I have an idea here. Make clean. Huh. Here's what we'll do. We'll go in and kill all the binary and object directories. That should bring us back into a hopefully working state. Make run. Right, okay. That's literally all that was. Just somehow poisoned our build directories a little bit. It's fine, and it happens. Okay, and yes, so we now have this title scene, you know, doing a weird scrolling effect, but it's cool. It's something. And I suppose if we now were to look at, I obviously closed VS Code. Let's go and reopen it. If we look at the tutorial here that we were looking at, there was some more things that we can do with that shader, I think, right? So this is actually just our normal source code, trying to explain how this all works. And here is where it says we can have a bit of fun with the values. So why don't we do just exactly that? So matrix view, this is literally in the title scene during the draw call, if I can draw. Here's the view, and I think what we'll do is I'll just copy this in. We mark this as a comment and say matrix view is actually this, which is matrix creates scale of 2, 3, and 1f. So in the three directions, you know, create a scale of 2x in the x direction, three times the scale in the y direction, and only one time in the z-axis or direction. Create a rotation pi over 4. That's a circle, isn't it? That's like a full circle. I don't know. And then you make a translation out of that. I mean, yeah. Right? And let's just see what that looks like. Make run. Yeah, indeed, it's definitely behaving entirely different. Not sure if I understand what is happening, but you know, it's doing something. That's actually cool. Um, so first I can get the width and height values from the viewport. Putting them into a local variable helps the code's readability. We then create a projection matrix. This projection matrix is used to convert from view coordinates into homogeneous coordinates which range from -1 to 1 on the x-axis and 1 to -1 on the y-axis. So the previous view coordinates end up looking like this. So instead of 0, 0, 500, and 1000, 0, you basically end up with -1, 1, 0, 1, and then 1, 1. So going up on the x-axis. -1, this should always be 0, right? And it's only the y position that changes over rows. Okay. Um, but this is exactly what we did then. Pass that shader on, and that's it. Right, the view projection is a parameter you passed in earlier from the type you can see that it's a 4x4 matrix that contains floats. Texture sampler is passed in by the monogame sprite batch. S means we get a sampler and the 0 is the index. Oh, thank you. The monogame sprite batch set that up for us. It makes it possible to sample from image, okay? Then this vertex input gets to pass to the vertex shader. Position is in the world coordinate. Now, world coordinate is that? Yeah, this is world coordinate. Really. Oh no, okay, okay, okay. This matrix is used to convert from world coordinates to camera coordinates. So this is the world coordinates, and then we normalize that essentially into these camera coordinates. Right, okay. Color is the value passed. Yeah, position is the world coordinate. Right, color is the value passed in the sprite batch draw call. Earlier we set it to white in the shader. Color becomes a floating point value between 0 and 1. For example, white is 1, 1, 1, 1. Okay. Text coord is in UV coordinates. It is a floating point value between 0 and 1. On the x-axis, 0 means the left side of the texture and 1 means the right side. On the y-axis means the 0 means the top and 1 means the bottom side. Okay, sure. The vertex shader here is used to apply the view projection matrix to the position that is in world coordinates. After the matrix multiplication, the position gets converted to the homogeneous coordinates that I mentioned earlier. If you say so, yeah. And this structures the result from the vertex shader that we generated. And the final step of the shader is to output a color for each pixel on the screen. First we sample the diffuse color for this pixel at the texture UV. Then the diffuse is multiplied by the tint color, okay? And yeah, here's our technique. Exposing the vertex and pixel shader. These lines work on the desktop GL and Windows DX platforms thanks to the defines from earlier. Yeah, okay. Uh-huh. Wow, okay. I'll say the shaders are complicated as fuck. To me, anyways. Um, I can't honestly say that I understand what any of these shaders do. Like, I know, like, code is normally the best documentation, but that also assumes that you have a very intimate knowledge of, I guess, the maths involved, and that's where it breaks down for me, unfortunately. But we were doing the vertex shader first, I know that. Then comes the pixel shader. So, right, in the vertex shader, we're getting some vertex input. So that's a vertex is a corner of a triangle. Okay. You say that the output position is the position times the view projection. This view projection thing is weird to me. Sort of where it all breaks down in these. Yeah. I think I would rather want to do a 2x2 scale for that. And then the translation creates a new translation matrix. With three fixed positions. Oh no, wait, times that. So matrix view is some matrix that makes a scale, this parameter, times a rotation of pi over 4. Like, what is that even? What is pi over 4? And I don't mean mathematically the number. I don't, like, that's easy. Like, you literally just 3.141 divide by 4. But what is pi over 4 meaning? Like, what does it signify? It's an angle of 45 degrees. It presents 1/8 of a full circle. So a full circle is 2 pi radians, or 1/4 of a half circle. So 2 pi is a full circle radians, like the not degrees, but the radians is another way of expressing those degrees. And pi over 4 is just an eighth of that, which if we just split that in as 180 brings it down to 90, brings it down to 45. Okay, I guess. And this is actually the number we would get out of that is 0.785, which is another way of expressing 45 degrees but as a radians unit. Okay. It marks the point. What? Square root of 2 over 2 times square root of 2 over 2. What? In the first column, where both sine and cosine are equal. I agree. Pardon me. Yeah, that's honestly not useful to me for me to understand, but it's what it is. I guess. What are we at? If I'm being honest, I think I've took this particular project as far as I can take it. Because ultimately we've now actually managed to do the shading and we've managed to do the packaging all up to what the tutorial suggested to us. And that's all helpful in knowing and understanding. I think for tomorrow we'll probably try and go back to Godot and maybe do something in that on that end of the spectrum. Close this. I think I'm going to call it for today. I really can't think of anything much to do with this except for, just changing numbers here and there and see what the result is. But it's not all that useful, right? We're not going to learn much from that. Just dicking around, as it were, without understanding what these matrices are and how all that comes together. I want to say though that I'm very happy with the result. Like, I'm not gonna lie, it's awesome. Let's say we have finished chapter 25, right? Added an extra, we'll call it a fun shader for the title. Shader for the title. What else did we do? That's it. Oh yeah, and we um, finished deployment slash packing of software or app. Like, that's basically it. Commit, sync. Oh God. We what? Interactive rebase because we fucked up something. Pick. Game scene. Okay, can we see this conflict somehow? Okay, resolve that in the merge editor and show me what's going on. Okay, we have 5 fucking conflicts. I want to accept the current. Next. Need to accept the incoming there because that's our grayscale effect. And load content from the asset pipeline, I think, is how I want to name this properly. That's our current state. I know that much. And what else? Game scene draw. I don't think there's a big difference between those. Not doing frame updates. We'll accept this one. And that should allow us to complete this merge. Continue, I guess. And then continue because I don't see any issues here. What's right, okay, yes. Commit. Hopefully that will have solved this for us or made an absolute mess of our code. We will see. Okay, it committed. It did the thing. Let's... Shouldn't have closed my browser just yet because we are needing to do something here. Go here. Make yes, 25, but wait, I want a new pull request actually, yes, from that. Yes, I think this is fine. Why? Well, I honestly thought we had fixed this shit. Copy, merge, commit message. Check out the new branch and test the changes. Oh my god, okay. Git fetch upstream origin chapter 25 slash chapter 25. Right. Uh, that was weird. Okay, we are already on that. Git switch main. Git merge no fast forward of chapter 25. And content MGCP and game scene. Accept the incoming change. Just going through in case I see any other right here. During frame update, so that's the incoming change we're accepting there, and that's it for that. What was the other one? Content. It's the incoming change and we need to accept here. Yeah, grayscale effect first shader, so they're both here. Okay. And once we have done that, copy, merge, commit message. Git push origin in. Everything up to date. Are you sure? Bless you.
Okay.
What's going on? Your merge changes. Right. This is just getting really ugly here, but it's fine. Oh, for goodness sakes. Yeah, I'm just making things worse here. I'm gonna just call it here because I'm literally just I'm breaking code here. I think left, right, and center, and I'd rather not. Let's go and raid out, shall we? Oh God. Where's my mouse? Thank you. Bring you over here. Let's go into the rate screen and we will have a look at who is doing things right now. Oh yes, absolutely perfect. Yes, let's go raid out in that direction. Let me go and set that up right now. Raid like thusly. We should find ourselves with a custom raid message in a second. Yes, indeed, is all looking good. Is the bot doing thing? I don't know what Frosty is doing, but Frosty is not doing a thing. Anyways, okay, guys, it is what it is. Guys, thank you so much for joining me today. As I say, tomorrow we'll go back to something similar, but probably look at Godot or maybe recreating this game in Godot. I don't know yet. We'll see how it's going and where my fancy takes me. With that, love you all. Couldn't do this without you. Look out for yourselves and each other, and peace out. Bye.